Okay, for the second two problems on the quiz, it says to find a power series in a standard form that is the same thing as, or that converges to, the given function. So first let me mention what the standard form means. It's the summation n equals k to infinity a sub n x to the n. So a bunch of stuff will be exactly like you see it in your answer if it's in standard form, like the x to the n. It's always possible to write x to the n as part of your answer, and the infinity will be there. Then you'll have n equals, that will be there too. Now the k will change from answer to answer. It might be 0, 1, 2, 3. That it just is where the n starts. Usually 0 or 1, but sometimes it might be a little bit off from 0 or 1. The x to the n is the only place that you'll see x in the entire problem. A sub n is just a function of n. No x is allowed. So it'll have just a sub n there, and then x to the n multiplied on, just like you see it. So it's a power series, power of x, n on the x, and it's centered at 0. In other words, it doesn't have x minus a constant, just x by itself. And we also know that that means that it's a Maclaurin series. So what you're supposed to do, though, is take this function, start with one of the main ones that we know already, and right now we only have the two. So on this one, I'm going to start with e to the x equals summation n equals 0 to infinity. That's just the word use. X to the n divided by n factorial. So that's a given fact. You need to look back in the notes a couple of days to see why that's true. We showed reason to believe it from a couple of different points of view, but now you can just use it. E to the x is the function that series converges to as a real number. So then there's 4 things that you can do to a given equation like this in order to get an equation for the function that we want. There's substitution for x on both sides. Then there's multiplying by a function of x on both sides, typically a power of x. Then there's integrating and differentiating. So on this one, the first thing I'll do is substitute, because I have e to the negative 5x. So right away, I can say e to the negative 5x is equal to, and I put in a negative 5x instead of x. So you have to think about blanking out the x that's there originally and replacing it entirely with negative 5x. That means I have to do the same thing to the x inside for it to be true. It's a substitution, like a u substitution, but I'm substituting a function of x for x, which is fine as long as you substitute on both sides of an equation. It's still true. So that's what it looks like, and you have to use parentheses when you substitute. Parentheses negative 5x all to the n. Okay, so it's almost there, but now I still have an x times it. So what I can do now is multiply by x on both sides. And I can multiply on the outside of that summation symbol, the big sigma. Just multiply both sides of the equation by x, and now I've got the left-hand side the way I want it. It's exactly equal to the original problem. On the right-hand side, though, I need to do some work, algebra, in order to make it look like it's in standard form. The one thing that I'm allowed to do is I'm allowed to distribute the multiplier on the outside of the sigma in through the summation. I can multiply it on the inside. And another thing I'm allowed to do is rules of exponents over here. So actually that'll That'll take care of it pretty quickly. Let's see. So distributing, have n equals 0 to infinity. And I'll go ahead and do the rules of exponents there. So I have negative 5 to the n, x to the n. Oh yeah, and I'm distributing this x inside. You can write it down either end because it's multiplication, commutative. So I'll write it just there for now, times x divided by n factorial. Better. Now I see x to the n there, but I have two x's, so I need to combine those powers. So it'll be x to the n plus 1. I'm going to spread this out a little bit. So negative 5 to the n, x to the n plus 1 divided by n factorial. Now it's almost there, but it's supposed to be in standard form, and now it has an n plus 1 instead of an n. So this is where you can do a substitution for n. I started with a substitution for x to get it to look like the problem statement, but now I can do a substitution for n to make it look like the standard form. So the problem is that I have n plus 1 here, and I want n. To do that, one way of doing it is to substitute n for n, and I substitute in for n minus 1. So all the n's that I see are going to turn into n minus 1. I know that that'll work out the way I want it to, because then I'll have n minus 1 plus 1, which will give me back x to the n like I like. So I'm going to substitute in that n minus 1. And let me just draw some arrows to show where they're going to go. Those two n's, and also that n, and also that n. All of the n's have to turn into n minus 1. Now, one thing I can do a little bit ahead of time, when I put in n minus 1 is equal to 0, I'll be able to add the 1 over, and it'll say n equals 1 at that point. So let me just do that on the side a little bit. If I have n minus 1 is equal to 0, I'll just say n equals 1, because I just add 1 to both sides. So I get summation n equals 1 to infinity, negative 5 to the n minus 1. I had to put in n minus 1 for all the n's. And this one, when I put in n minus 1 here, you could show the work and say n minus 1 plus 1. Or, now I'll write that on the side too, n minus 1 plus 1. You can say that just equals n. So you can do that in your head if you want. So that's going to be x to the n. And the n minus 1 underneath needs to be in parentheses. And there's the final answer. It looks like the standard form because it has x to the n, and that's the only place that the x is located. All the rest of the x's have been absorbed into that one x. Don't have any other x's, and it has an n on top of it. I got them all together here, but I still had a plus 1, so I needed to do that last substitution. And there's the rest of it now has n minus 1s everywhere because I had to substitute in. So it has negative 5 turned into n minus 1 factorial underneath, and n equals 1 to infinity on the outside. Now this is where on that last step you can do a double check to make sure that you substituted correctly. It takes some practice to get good at that because you have to substitute in for all 4 of the n's, and there may be more sometimes or less, and it's easy to make a little mistake. So what you can do is just start expanding it. Like just before this step, it was, so here's my double check. Before this step, it went from n equals 0 to infinity, negative 5 to the n, x to the n plus 1 over n factorial. When I plug in n equals 0, I get negative 5. So this will be n equals 0 on this side. I get negative 5 to the 0, x to the 1 divided by 0 factorial. Now I better get that same thing when I start at n equals 1 in my final answer. And it does. When I plug in n equals 1 here, I get negative 5 to the 0, x to the 1, and 0 factorial. So, in the final answer, that works with n equals 1. Now, I should point out that if you use another letter instead of n, it would technically still be right. People use I, J, sometimes K. I used K here, but since I ended up making it a number like a 1, it doesn't matter what you call n. You could call it K if you wanted. So if you've seen it like that before somewhere, that would be okay too. But I just decided to use n all the way through here. All right.